So today we start semiconductor electronics, material devices and some simple circuits. So today we start semiconductor electronics, semiconductor electronics and materials, uh, devices, semiconductor devices mainly, and some simple circuit, and some basic or simple circuit. Okay. So in before 1948, okay, because the 1948 at the discovery of transistor, okay, the discovery of transistor, a device, okay, a semiconductor device named transistor. Transistor means transfer of resistor, okay. When we discuss transistor, then we detail discuss about what is transistor, okay. So now in this syllabus, class 12 syllabus, the basic idea about what is semiconductor, some semiconductor device, material and basic simple circuit, okay. So before discovery of transistor, before 1950s, okay. Okay, so there is a mostly used in vacuum tubes. So they are used in vacuum tubes. Vacuum tubes. Okay, and this vacuum tube have two electrodes. That's the two electrode mainly. Two electrode, and we know that one electrode name is a cathode, other name is anode. Cathode and anode. The two electron means two metallic connect, and this is a cathode and anode. Some books say that is anode is another name is called plate. Okay, so anode and plate both be the same. Okay, so these are the called vacuum tubes. That mainly the two electrodes, cathode and anode, the two actually two metallic contact. Okay, and there is some another device called pentode, tetrode. Suppose the tetrode have 4 electrodes, pentode have 5 electrodes. So other devices is like a name of tetrode have 4 electrodes and pentodes have 5 electrodes. Okay, and these are some vacuum tubes. And 4 electrodes means a 4 metallic contact. There is a 2 electrodes, a cathode, anode or plate, and there is a 4 electrode, 5 electrodes. Okay, the operation is look like a valves or vacuum tubes. Valves or vacuum tube. The operation is very complicated. Okay, operation is very complicated. Like that, when we apply some electric field, when we apply the electric field, like when we put a anode with a plus and cathode with a minus, when we apply some electric field, so the electron release from cathode and move towards the anode. Okay, when we apply the electric field and electrode in electron, so electron flow from cathode. When we applied electric field on electrode, then electron flow from cathode to anode direction. Okay, that's the basic operation of the valves or vacuum tubes. Okay, but there is some demerits. Okay, demerits is like that when an electron flow, so there is some collision. If there is a collision, so a heat is generated. Okay, so that heat is through the devices. The devices are very bulky and consume high power, operate a high voltage, suppose 100 volt, and low reliability. More heat is generated, and longevity is very low. These are basic demerits. That's why in 1950s the transistor was invented. So update of vacuum tubes. Okay, upgrade version. So demerits is very important. Why semiconductor device is important for, because there are less of insufficient of that or demates of that valves or vacuum tubes. So demates is very important. Demates. When electron flow, so actually when electron flow, so heat is generated. So first demerit, heat is generated. Actually not heat, with very high heat is generated. Okay, very high value of heat is generated. Okay, why? Because the pollution of electron, on electron collide, so there is a heat is generated. Second demerits, is a device are very bulky device, uh, bulky device. Third demerits, that is operating voltage is very high. Operating voltage is very high, approx suppose more than 100 volt. Okay, there's operating voltage very high. Low reliability, very low reliability. These are the demerits of bulbs or vacuum tubes. That's why the transistor invention is very important. Okay, so now jump into the modern era. The transistor era is called a modern era. Now we jump into the modern era. Modern era. After 1950s. After the modern era, we jump into the semiconductor electronics. Jump into semiconductor electronics. Actually, the semiconductor electronics starting from 1930s. Okay, but the main device transistor was invented in 1948. So here we discussion limited discussion here in solid state semiconductor. Is a solid state semiconductor. Okay, the solid state semiconductor. So mainly that device is very important or function very fast because they have junction. They have junction. The junction is very important. So what is junction? Later we discuss what is junction. But junction is the main important or key factor for difference between the bulbs and the semiconductors. Because semiconductor have junction. Okay, that just junction is vast different. Here a very high reliable than bulbs. Okay, so a junction, and this junction mainly the control the flow of electron. This junction mainly control flow of electron. Here you see that when we discuss a vacuum tubes, there is an electron flow, and electron flow is control is very typical. Okay, because there you control first applied electric field is suppose increase or decrease, then we control the electron flow. But here we control the electron flow. Okay, mainly the control the electron flow with the help of junction. The lack of junction, the vacuum tubes are fail. But here the semiconductor is mostly successful because they have junction. And this junction mainly the control the flow of electron. Okay, this flow of electron is called another name, very important name is called carrier. Okay, called carrier. Carrier. So advantage of the semiconductor devices. What is the main advantage? Okay. So advantage of semiconductor devices, mainly advantage of semiconductor over bulbs or vacuum tubes. First advantage, okay, is a low power. use very low power, okay, low heat. Number 3, high reliability. Obviously compared than in valves, okay. Number 4, small in size. Number 5, operating very low voltage. Operating very low voltage, because the valves or vacuum tube use as a suppose 100 volt, more than 100 volt. Okay, these are the very low voltage application here. So that's why semiconductor device is more successful than vacuums. So here is some take an example in vacuum tubes. Some name of vacuum tubes. Some example. Actually, we use that. Okay, suppose a CRT, cathode ray tube. Cathode ray tube is the most important example of vacuum tubes. Okay, because that electron released from cathode and move towards any photosensitive plate. Okay, so they get some cathode ray tube. Okay, and this cathode ray tube, actually the best vacuum tube, is replaced by liquid. Replaced by liquid, and you get LCD, liquid crystal display. Crystal display. And now we use that LED. Okay, that's very vast devices here. But first the CRT replaced by the LCD, and now the LCD also replaced by the LED. Okay, now we jump into the basic semiconductor devices, mainly the semiconductor science. Actually, we have the discussion or the immediate discussion on semiconductor science. So jump into the basic semiconductor science. Semiconductor science. What is the science behind the semiconductor, like that? So the idea is that, okay, the mainly we divide the semiconductor mainly divided into two parts. So mainly the conductivity and resistivity. Okay, so there are the three types: of the metal, insulator, and semiconductor, and differentiate between these three with the help of conductivity and resistivity. So first we choose some metal, okay, and suppose a semiconductor, or you can say finally say that is an insulator. Okay, metal, semiconductor, and insulator, and we some parameter. The mainly two parameter here discuss: the conductivity and resistivity. The conductivity is represented by sigma and resistivity is represented by the rho. Okay, so here for metal have good conductivity and low resistivity. Metal have good conductivity but a low resistivity. So conductivity of metal, suppose the conductivity range around to 10 to the power 2 to up to 10 to the power 8. This is a good conductivity, and SI unit is Siemens per meter. Okay, and the resistivity, the rho, the resistivity is very low, suppose 10 to the power minus 2 to jump into 10 to the power minus 8, very low, ohm meter. The semiconductor is between metal and insulator. So insulator have very low conductivity and very high resistivity. So conductivity is very low, suppose 10 to the power minus 11 to 10 to the power minus 19 Siemens per meter, but resistivity is very high. Suppose 10 to the power 11 to 10 to the power say that is 19, very high ohm meter, very high resistivity of insulator. So what is semiconductor? Semiconductor is in between metal and insulator. So there is a moderate resistivity and moderate conductivity, like a suppose 10 to the power 5 to 10 to the power minus 6, and here 10 to the power minus 5 to 10 to the power 6 ohm meter. Okay, so sometimes metal semiconductor behave as a metal, sometimes metal semiconductor behave as a insulator. That's because the semiconductor have a junction. Okay, further discussion what is junction here. Okay, so metal have good conductivity but low resistivity. Insulator have bad conductivity and good resistivity, but in between we place with semiconductor. Okay, so that's why semiconductor is very important. Sometimes behave as a metal, sometimes it behave as a insulator. Okay, so there are types of semiconductor. Mainly our discussion bound in semiconductor. So that's why we discuss only in semiconductor. So semiconductor, types of semiconductor, types of semiconductor. Okay, so there are the mainly two types of semiconductor: the elemental semiconductor, or is a compound semiconductor. First is the elemental semiconductor, and second part is a compound semiconductor. Okay, so elemental semiconductor like a silicon, germanium, these two are the elemental semiconductor. And compound semiconductor have some three categories: inorganic, organic, and organic polymer. That's very important. So compound semiconductor have three parts. Compound semiconductor. Okay, so three part. First is the inorganic, organic semiconductor, and there's an example like a cadmium sulfide, mm, cadmium sulfide, and other device is called gallium arsenide. Okay, and uh, cadmium selenide. These are the or another indium phosphide. These are the basic four inorganic semiconductor: cadmium sulfide, gallium arsenide, okay, cadmium selenide, and is a indium phosphide. Okay, these are the inorganic. Second is a organic semiconductor. Organic semiconductor. So take an example of organic semiconductor is called anthracene, dope, phthalocyanidis. Okay, these are the basic organic semiconductor. Okay, mainly this not discussion here. You have taken some example, and you get a NCERT book. You have some example here. Okay, and third part is third mainly. The name is too little bit complicated here. Third part is a organic polymer semiconductor. Organic polymer semiconductor like a polypyrrole. Okay, uh, polypyrrole, polynylene. These are the mainly that organic polymer, and that's a very important here because organic polymer, um, polymer. Okay, jump into that. Jump the polymer electronics. Okay, these are very important for polymer electronics. Okay, so here are the basic types of semiconductor: elemental semiconductor, compound semiconductor, three parts of compound semiconductor: inorganic, organic, and organic polymer. Okay, so here we start into the next concept is called basis of energy band. What is the energy band? That's a very important concept. Here we start a discussion of energy band. Okay, so before we jump to energy band, the polymer electronics or molecular electronics, that's a futuristic technology. Okay, these are keep in mind. Today the modern generation are research on that polymer electronics, molecular electronics. Okay, so now these are a basic discussion or limited discussion of the basic of energy band. Energy band of energy band. Okay, so what is energy band? according to the Bohr model, okay, so isolated atom, so actually the element have huge number of atoms, okay, million numbers of atoms, so the in isolated atom have some energy of electron, okay, and is decided by the orbit, okay, and this orbit, it is revolve actually, okay, electron are in revolve, okay, like a planetary model revolve when it come closer, when the two atoms are very close or very close, so the outer orbit nearby atom, if when two orbit are very close, so outer shell electron, okay, the outer shell electron very close, so like a they like a overlap, okay, and it look like a band. So here comes to mind the according to Bohr model. Okay, so write down the, if you write to notes, so pause the video, write some notes. Okay, so according to the Bohr model, according to Bohr model, Bohr model, right, isolated atom, isolated atom. Okay, the energy of electron, mainly the energy of electron, okay, is decided by the orbit, the orbit, and which is revolve, which it revolve, okay, when it comes closer, when two atoms comes very closer, when atom comes very close, okay, very closer, so like the outer orbit of nearby atom, so the outer orbit of nearby atom, so the element have a huge number of atoms, so the two similar kind of atom are very close, and so like they're very close, we're too much very close, so close look like they are overlap, okay, and look like band atom, so they overlap, look like actually overlap, and to form a band or to look like a band, like band. So each electron have different energy, okay, so they have some different energy level, and this different energy level is called energy band. So what is the energy band? So each electron, okay, so each electron have some different energy, have different energy, okay, keep in mind these electrons have different energy, so that they have different energy level, so they have different energy level, okay. Next point, if they have different energy level, this different energy level is called energy band. So these different energy level is called energy band. Keep in mind, these are the energy band. Okay, so now there's a two type of band. One is the valence band, other is a conduction band. So there is a two types of energy band. There is a valence band and conduction band. Valence band and conduction band. Conduction band. Okay, so valence electron, you know that the in chemistry, the valence electron are in valence band, and conduction electron are in conduction band. Okay, so valence electron valence band, conduction electron in conduction band. So there is actually the band, draw a diagram, is a band now is look like this. Suppose say that is a conduction band, and if I say that is a valence band, okay, and this is that actually these are the energy, Okay, so that is the energy E in that direction, and this is the lowest part of the conduction band. Lowest part of CB, and that is the highest part of the VB. Part of VB, and you see that lowest part of the CB is greater than the highest part of the VB. If I say that lowest part of the E energy of lowest part of CB, and if I say the energy highest part of VB, and you say E lowest part of CB is greater than E highest part of VB. You say that there is the energy gap here. This is the energy gap. Okay. So normally valence band are filled by the electron. Okay. So outermost electron are in valence band. So the outermost electron in valence band. Okay. And valence band always filled. Valence band are filled by electron. Clear? And conduction band is empty. And conduction band is empty. Conduction band is empty. Valence band are filled. So these are basic normal diagram of a normal condition here. For normal condition, for normal case, but when you treat it as a metal or use conductor, treat it as a conductor. So treat it as a conductor. So this is the look like this. This is the conduction band. This is the lowest part of the conduction band. Okay, and that is lowest part of the conduction band. And now these are the valence band. Okay, these are the valence band, and this is the highest part of the valence band. Okay, and you see that there is band of overlap. So electron in valence band, so that electron are also in conduction band. So here electron in VB, so they are also in CB, and so now the electron easily conducted. Okay, so current flow easily you get. Okay, so current flow when electron jump from valence band to conduction band, so you get some current. When you get current when electron jump from valence to conduction band, but in case of conductor or metal, we see that valence band electron are always in conduction band, because the band, so that is the lowest part of the conduction band, that is the highest part of valence band. Obviously highest part of valence band is higher than the lowest part of conduction band, so that's why the band of overlap, so electron in valence band are also in conduction band. Okay, that's the basic idea. So here that energy gap, here you see that gap is called Eg, energy gap. Okay, so in case of metal, the energy gap is very high. So for metal uh, in Eg, but in case of metal, Eg is 0, because there is no energy gap here. Okay, there is no energy gap, so here is a Eg is 0. So in case of metal, the Eg is 0, but insulator, Eg is very high. Eg is very high, very complicated to when a valence electron jump to conduction band. For in case of metal, in case of insulator, electron jump from valence band to conduction band is little bit difficult. Okay, so that's why you do not get a current in insulator. Insulator is very bad conductor of electricity, because that conduction band, the lowest part of the conduction band, and that is a valence band, the highest part of the valence band, the Eg is very high. So electron jump from valence band to conduction band is a little bit difficult. Okay, so that's a basic idea on discussion further. Okay, later we discuss here. So now we study how the band is look like. Actually the band, actually I draw a band like a stable here, but how the band is look like. how band is look like. Important question, how the band is look like. So if we choose a silicon elemental semiconductor, the atomic number is 14. So electronic configuration is a 1s2, and that is a 2s2, 2p6, 3s2 and 3p 3s2, 3p2. For last cell you see that it is a 4 electron. Last cell have 4 electron. Okay, mainly that last cell means the outer orbit. So outer orbit have 4 uh, 4 electron here. Okay, so outer orbit here. Okay, so these are outermost. So 4 electron means these 4 electron means that the 4 energy state. So 4 in energy state. Okay. So 1 electron means 1 energy state. So 1 electron, that is 1 energy state. These N stand for energy state, and 4 electron means, so 4 in energy state, so 2 electron, 2 n, 3 number 3. Actually these are number. Okay. Okay, and these 4 n or 4 electron are in VB or in VB, because we know that valence band always filled. Okay, valence band always filled by electron. Conduction band is empty band. Conduction band is empty band, but valence band is filled band. So silicon, last cell of the silicon, 4 electron. These 4 electron are occupied in valence band. So valence band have the 4 n energy state. Okay, but the last cell have a possibility, mainly the 8 electron capacity is last cell is 8 electron. The capacity of last cell, we know that capacity, that is 8n maximum possibilities. So max possibility have 8 electron, means if the 8 electron, so that's the 8 n energy state, because one electron has some energy. So the one electron has some energy means one energy. Electron means here the energy, and there's a one electron are in that level when that energy level are same as the electron energy level. When the energy level are same as electron energy level, so that electron belongs to that energy level. Okay, so the 8 n discrete energy level. So maximum possibility of that each band have 8 n discrete energy level. So that's the 8 each band or valence band have 8 last cell have 8 n discrete energy band. Okay, discrete energy band. These are not continuous, keep in mind, these energy band are not continuous. Okay, these are the discrete, and these discrete are split together into band, and these are split into band, split into form a band. Keep in mind, split into band. Suppose we say that it choose a carbon. So the carbon, so carbon have atomic number 6, so configuration is a 1s2, so 2s2 and 2p2. So last cell have 4 electron. 4 electron means 4 n energy states are filled. So here draw is a band is look like this. Suppose okay, these are called spacing between the atom. These line x-axis between the spacing between atom. Okay. These are spacing between atom, and suppose when you choose a 2s2 and 2p6. Okay, so the if a spacing between the two atom is very less, actually the band is from what we previously discussed. When two atom are very close together, so they look like they overlap. Okay, so here we discuss here first. uh, okay, and these are when two atoms are very close. Okay, atom are very close, the outer orbit nearly the atom are overlap. Okay, these are keep in mind when an atom are comes very close, so like they are overlap. Okay, so atomic spacing between two atoms here in this graph, spacing between two atoms target to very less. So now there's suppose that is a 2s2 here. Suppose there is a 2s2 last cell, and that is a another, that is called here, that is 2p2. So when the spacing between them is very less, they are split. They are split, and split is look like this. They are split. Look like this. They are split, and similarly they also split. Okay, and here we see that when they are split, and at that point, okay, this goes this direction, and this goes downward direction, and this band also split here. It goes downward direction, this upward direction, and here we see that this point, okay, and this here, and that point here, this point. There here we see that here this part, and see that there is 8 n state. Maximum possibility is 8 n state and occupied by 8 electron. Mainly 8 n state have 8 electron. But here in that case, the 8 n state are here. 8 n state here, but have only 4 electron. Here 8 n state and 4 electron in carbon. Okay, and here at that point, band here at that point, uh, at that point here, okay, here is empty, and this here is a 4n energy state, and here also the 4n energy state, and this 4n occupied by these 2 electron are moves in that, and these 2 electron are here. So here also that 4 electron, 4n states and 4n electron. So these are the field here, these are the field, and these field, and here in that direction has energy plot in that direction. Okay, and these are the field here, and that's why this band is called valence band. This band is called valence band, and this band is called conduction band. Conduction band is empty. For instance, here, but no electron here, and here 4n state and 4 electron. There's a field, valence band, and these here, this line or this line, okay, is called energy gap. Energy gap. These 2 electron here, these 2 electron here, and there's these upper part is empty, upper energy part is here empty. So the 4n state here, but the all are empty. So conduction band is empty. These 2 electron goes here, these 2 electron goes here. There's a 4n state here, this 4 electron here, and these are field. So that band is called valence band. Okay, these are actually the band here. Okay, and these are the continuum discrete level. These are mainly the continuum continuum of discrete level. Okay, so here 4 state occupied by 4 electrons. So 4 state n state occupied by 4 electron here. Okay, and these look like appear, these discrete is appear to be band, appear to be band. Okay, these are the actually the band structure, or say the basic idea about the band diagram. So here now final, and see that here the conduction band. Okay, there are the 4 n state here, okay, 4 end state, and here is empty. And this part is called lowest part of the conduction band. I say that EC, and here is a VB, valence band, and here also that uh, suppose 4 end state here, and these are filled by 4 electron. Okay, and this gap is called EG, energy gap. Okay, clear? The 4 electron are filled here. Okay, so 1 2 1 2, these are the 4 electron are filled here, and these are the gap here. These are actually these graphically are represent look like band ST. So there is some energy. These direction represent that energy. Okay, so these are the basic idea about what is a semiconductor. Okay, so next class we details more details about the what is that band diagrams look like, what is the electron energies. Okay, what is that energy gap, what is valence band, conduction band. There are two types of semiconductor: intrinsic semiconductor, extrinsic semiconductor. Okay, jump into the diode structure, diode diagram. So that's a lecture in here. So this lecture take little bit long. Okay. So that's why today in the class here. If you have any doubt, please ask in comment section. I will try to give the answer. So we meet again in our next lecture. Thank you.